Welcome to Out of the Blank.
Welcome to another episode of Out of the Blank podcast. I'm here with Brandon. Brandon, it's a pleasure to have you on the show. If you want to introduce yourself to everyone out there listening.
Sure. Yeah, I'm Brandon Johnson. I'm an associate professor at Purdue University, and I study impact cratering, mostly through numerical modeling. But essentially, my job is to smash planets.
Why impact craters, though? A lot of people study different parts of a planet, like exoplanets. You can study which ones would be more habitable for life. People are looking for resources on some planets, maybe one that they can mine or do something towards. I've gotten really interested in the space topic, like I was telling you off air. I'm just curious why you would choose impact craters, and if those impact craters have some type of possibilities to maybe a prediction of how sensitive our planet is, for instance. I don't think people really understand how many asteroids have just missed us without us even knowing.
Sure. Yeah. So, I mean, the true answer is that I kind of stumbled into impact cratering as an area of research in graduate school. I ended up randomly meeting my advisor who wrote the book on impact cratering, and I just got fascinated with it after that. And the study of impact cratering requires a pretty serious knowledge of physics, because there's a lot that happens during an impact cratering event. And so I was really attracted to it from that standpoint. But you know, what I tell people more professionally now is that impact cratering is a really is an extremely important process in planetary science. Essentially, all the planets were built through a series of mergers and impacts, and their surfaces continued to evolve through impacts. And so it's very pervasive process that happened and is continuing to happen in the solar system and in other planetary systems.
What are some key examples of some like maybe beneficial information we have learned from impact craters? I'm just trying to get like a basis of like what question I'm trying to think of, because I'm like, I look a lot of people, like the general public, I would say, that's not involved in this is going to be thinking an impact crater. That's what a mark that's left from a comet or some type of rock hitting another surface or something. But I don't think people understand. Like, we all saw the Netflix thing where it was like look up, or was it don't look
Yeah,
up?
don't look up. Yeah.
So as hysterical as that might have been, of like I guess making fun of an event or something like that, you have to understand like that something even as small as a pebble can really cause a severe amount of damage when it's falling like so fast at a speed or rate that you can't even really comprehend. I mean, we don't know how fast that is. We know, like, oh, I could say to miles per hour, 30,000 miles per hour. Well, a lot of people don't know what 30,000 miles per hour looks like. That's like the flash. You don't see that, but that has drastic impact to changing the whole shape of a planet and how it forms.
Yeah, I mean, the numbers, yeah, the speeds are hard to wrap your head around. But typical impact velocities on the Earth are something like 20 kilometers per second, which, like you said, it's hard to really wrap your head around that. But sometimes people are more likely to connect to things like the energy equivalent in like the TNT equivalent. So um, people might remember, like, in 2013 there was this big fireball or air blast in Russia in a near city called Chelyabinsk. Um, that was about a 500 kiloton event, and that was something that blew up in the atmosphere. And so the things that make craters are bigger than that. And so the amount of energy that these things release is oftentimes much larger than any atomic bombs that exist, even hydrogen bombs. And some of the impacts that have happened historically are more energetic than the entire nuclear arsenal of the world. And so I think in terms of what the general public might connect to, certainly hazard from impact is a very a real thing that people can think about, and scientists are concerned about. Um, Another thing along the lines of hazard is we had about a 10 kilometer, several mile wide, mountain size asteroid hit the Earth about 66 million years ago that killed off the dinosaurs and a whole bunch of other species in what we call the Cretaceous Paleogene mass extinctions. And it's really the reason why humans exist. It's why mammals came to be a dominant species, and why humans are around. Otherwise, we'd probably be literally we'd be like lizard people. We dinosaurs wouldn't have had much of a reason to have their reign ended if we didn't have that big impact happen.
Where would the most valuable information that these things could honestly give us? Like, because the way I'm starting to hear it and kind of think about it is this is a great way to detect if that there was other life on another planet at some point in time. Mostly if you can check an impact crater or see that one has a giant like Mars or so, like Mars, for instance, they have giant impact craters all the time. There's pictures that always getting put up. People suspect that Mars is alien life or has some type of form of it, or it might be there. And I start to wonder when you see these giant pictures of impact craters, is a possibility that if they do end up finding something, it would be on a planet or something that has these giant impact craters. I mean, the fact that one impact crater or one impact to us, and we are able to come from that, it might have wiped out the dinosaurs, and then you see this life start. Is there maybe it's a possibility that another planet that had an impact crater of that size might not have had the possibility to grow life after that? So it kind of looks like it's kind of like a heads or tails situation. Like we're heads over here, and then over there would have been tails.
Yeah, yeah. So that's a really great insight. So yeah, so impacts can maybe may give life, and they may take it away as well. So a lot of people think about really big impacts, so even bigger than the one that killed off the dinosaurs, as things that could sterilize the planet. So they can boil off the oceans and kill anything that's at the surface. So people think about those kinds of impacts as making it very difficult for life to be around. And we think probably 4 billion years ago on the Earth and other planetary bodies, those impacts were common enough that really if life did start, if life did come about, it would have been sterilized, by a large impact. But then there's other things that impacts can do to help life. Like you said, in this case, killing off the dinosaurs was good for mammals, which was eventually good for us. Um, uh, Impacts can also be beneficial to life just starting out, like microbes forming. So um, we think about impacts generate a lot of heat. They might make things like hydrothermal systems. So people may have seen these images of hydrothermal systems at the bottom of the ocean with little crabs and worms and stuff. And this is like a separate environment from most of the stuff that we think about on Earth. But there's some evidence that hydrothermal systems might have been a good place for life to originate from. And so impact produced hydrothermal systems might be a good place for life to originate on other bodies. Also, the impacts, so the impacts themselves, the bodies that are hitting bring a lot of materials that might be beneficial to life. So the reason we have oceans is because at some point bodies that were rich in water hit the earth, depositing that material and letting us have oceans. We could think about other materials like carbon and phosphorus and nitrogen and all these other things that life needs, and that's originating from these impactors. So if you get too big, you can sterilize a planet, but you need that flux of material to bring the ingredients for life to a planet. So it's potentially very important on both sides of the sword.
So the reason why I call this show a conversation, not an interview, because I'm going to have these far off questions like I just had. So with technology, the way that it's increasing, for instance, the probability you're going to be able to predict, be able to really scope out impact craters and also be able to kind of, because impact craters are a sense of like, if you see a house with a bunch of holes in it, you're probably not going to want to buy that house. So if you're looking for exoplanets, for instance, you're probably going to want to find a planet that doesn't have so many impact craters. At the same time, I mean, we don't know where technology is going to go. If it's going to increase in terraforming, we'll be able to drop microbes or do something to add more sustainable conditions for human life to be able to expand out into the universe, whatever you want to say. But I look at this kind of thing of like, I see someone with a map that goes, look, that planet obviously has a lot of impact craters. So let's not go there because it's probably prone to getting hit by asteroids. Let's go to the one that can sustain life a little bit farther away, maybe a little bit more resources, but only has one impact crater out of the whole time that we've seen it and scoped it out, which predates it to whichever, a very extended long time period. They're kind of looking at the cost reward type thing. Is the cost of maybe a little bit more resources to go a little bit farther out for a better sustainable planet with a less likely chance of being hit by an asteroid because maybe it's some other calculation out there that say might be so far out. I mean, as much as it might be beneficial for life, like bringing in a new resource to the atmosphere, bringing when it hits, and maybe it adds something different. Like, for instance, we could have an asteroid that hits and it could be a small impact, but maybe it could reduce a lot of the carbon. It could do something. It could have it could be something that random that we never even could think of, but it's a random occurrence that happens. But also the probability factors of being able to kind of see if the next sustainable planet will be one that would be with less impact craters.
Yes, that's a good question. First I'm
Told you
going
I'm
to
out there. I'm out there.
yeah, no, it's good. So first I would say I think it's a long ways in the distance until we have images of exoplanets that are good enough to be able to say, look at the craters on them. Um, but that's fine. The question is still a fun one. So I think another thing to consider is that uh, just whether a body has a lot of craters or not doesn't necessarily tell you about how likely it is to be cratered in the future. So a really good example of that is the moon, right? So when the moon's out, you can look at it, with your eyes and see that there's these big basins that have been filled with lava. Or if you have a telescope or binoculars, you can see all the craters on it. And people have seen, images of it and know there's lots of craters on the moon, right? The Earth, for every asteroid that hit the moon, there should be about 20 or so that hit the Earth of that same exact size. And so the Earth really should be just this heavily cratered, hellscape. But instead of that, we have things like we have plate tectonics, we have an atmosphere, and we have a lot of water and a hydrologic cycle. So we have rain that erodes things away, and so we don't see those craters because most of the terrain on the Earth is relatively young, right? Whereas on the moon, most of the surface of the moon is about 4 billion years old or so, and so it just looks this, very heavily cratered. So just seeing the number of craters doesn't necessarily tell you how likely impacts are. What you really want to know is what's out there that could be hitting you, right? So you'd want to know what the asteroid belts or the Oort clouds or where comets are coming from on in these other planetary systems look like. And then you figure out what the orbital dynamics are, and you can calculate what the chances of getting hit are, right? And so that's the kind of thing where you'd want to look at. And then from there, you'd probably want to look at the planets and say, oh, well, this one has a lower likelihood of having really big impacts, and maybe that's the one that we want to look at. I think before that, you'd want to look at like the habitable zone and things like that. But
I always look at us kind of like we're going to make the mistake anyway. It's kind of like if I give you two options to choose to have your home, I guess, in like a nice, very farm like area, or just choose to have it in Egypt. People are like, I'm going to choose to have it in Egypt. It's like, well, why? You can see that it's not habitable, but they're like, yeah, but there's nobody here.
yeah,
Fair point. But man, see, because what about like for instance, the moon has a lot of impact craters on it, but then there's the other side, the dark side of it. Now, do we know if there's impact craters on that side as well too? I'm guessing there obviously is, like just from a logical standpoint, that it's not just going to hit only one side. But I mean, we're not able to measure properly, or is there better scope of that, for instance? So just because it's if it is it 100% dark? Like that's all I know. Like I said, the general public, they hear the dark side of the moon, they figure that sunlight never hits that aspect of it.
Yeah. So that's a great question. So yeah, just I like Pink Floyd as much as anyone else. So I like the dark side of the moon as well. But really, what we like to refer to it as the near side of the moon and the far side of the moon. So the side that we see all the time is the near side of the moon, and the other side that we don't see from Earth is the far side. That being said, both sides have day and night just like on the earth, so there actually isn't really a I mean, at any given time there's a dark side of the moon, but it's always changing, right? Just like we, when it's nighttime, we're on the dark side of the earth, right? And there's plenty of sunlight on the far side of the moon, and actually we have seen it in great detail with spacecraft. And so we do know about the craters on the far side of the moon. It's actually more heavily cratered than the near side of the moon. One of the biggest craters in the solar system is actually on the far side of the moon. It's almost 2,000 kilometers in diameter, so it's really, really big.
So wait, hold on. So here's a different question, but with the planet's alignment, which planet in our solar system gets hit with the most asteroids, or gets has the most impact craters on it?
So which one has the highest impact cratering, like, today?
Yeah,
Is
because like, isn't Mercury or one of those planets is like our shield in a sense? Its gravity pulls a lot of asteroids or debris away from our, I guess, track in a sense. It kind of saves us. Because if you look at like planetary defense, or if you look at like any of these asteroidal impacts that could possibly hit Earth, there's a lot that happens, but it just misses us and we don't even know about it.
Yeah, so I mean, so part of that is just space is really big, right? So in fact, if you there you know you might see it in the news a lot, like, oh, this asteroid passed within the distance between the earth and the moon. But that's a really large distance. So even hitting that big sphere that includes the distance to the moon is a lot harder than hitting the little earth in the center of that kind of target, right? So you could think about that as, when you read those news stories, the earth is a bullseye, and they're just going between the earth and the moon is kind of like hitting a big target. um, the dynamics of what is going on when we have earth crossing asteroids and potentially hazardous asteroids. A lot of earth crossing asteroids, so that means the orbit of the asteroid crosses the orbit of the earth, not at the same time the earth is there, because when that happens, that's means the asteroid hit the earth. um, but so when you have those earth crossing asteroids, a lot of those will end up hitting Mercury or Mars, or some of them will actually get get close enough to the sun that they get flung back out into the outer solar system, or actually out of the solar system completely.
So that question was, so the Mercury one, I think, is the one that was been known as like our shield in a sense, because its gravitational pull can sometimes pull in some of those asteroids and just knock it off track from coming towards Earth or coming closer to us. I wonder how many asteroids it would take for a planet to start developing a possibility or capability of becoming one of our exoplanets. Like, you start looking at human conditions, for instance. Human conditions are changing all the time when it comes to pollution. Some places are harder to breathe, but people get used to it, they adjust, and next thing you know, that's normal to them. And then they go to like an open wide space, like, oh my God, I can breathe again. It's like, yeah, well, you got so used to living in a city for so long that now you're adjusted to that climate. I just wonder if a small asteroid or something, like I said, it's a hypothetical out there, but if something has a resource or water or some type of thing that could hit Mercury or something that would be something that we know we can't live on now. But then what? That happens and then it changes everything. Like that's the really weird part about information and all the stuff that we have. Now we can say like I'm a big fan of science, but I notice that science changes rapidly sometimes as well too. And those are just drastic changes or possibilities that we can't see. That's why like the whole probability factor when it comes into like you could with impact craters or with anything that just involves trying to figure something out. Usually you're basing it off of a probability. And Mercury, for instance, if that gets hit by a lot of asteroids or has a lot of impact craters on it, I start looking at which planet has the most impact craters on it and how many is it going to take for it to completely change. I mean, in a sense, impact craters are not only a way to tell if something is ever going to get life, but at the same time going to be able to tell if it hasn't gotten it so far after all these impact craters, then it's probably not going to be possible that this is going to change. So that science would be set in a sense.
Sure.
That was
Yeah.
a long-winded one. I'm sorry.
Yeah. No, I'm trying to piece it apart. I had an answer, and then I was like, oh wait, then there's another one. Okay. Yeah. So I'll maybe try to come back to the first part. So so when we think about impacts on Mars or someplace, uh, if an impact's large enough, it could create like a transient atmosphere. Or I mean, Mars has an atmosphere, but we could have an impact that's large enough that makes the atmosphere more dense and potentially, in a transient sense, makes Mars more habitable. I mean, you might have seen, like, I think it was Elon Musk was tweeting like nuke Mars to terraform it, right? But honestly, having a big impact would have a very similar kind of uh, uh, impact, for lack of a better word. But so we have an asteroid, like let's say an asteroid hit one of the polar caps on Mars. It will release a whole bunch of water and water vapor, and it may, for a short term, in a geologic sense, maybe tens of thousands of years, maybe hundreds of thousands of years, could make Mars a slightly more habitable place, or a place that's a little bit better for uh, things that we know that live, thrive on Earth could thrive there. Mercury is harder because Mercury doesn't have a lot of water or other things that would be able to make a nice atmosphere. Um, so I don't know about future impacts making Mercury more habitable, but certainly on Mars it could be. Um, but the in the current in current time, really big impacts are quite rare. If and you need a pretty significant size impact to you know totally change the atmosphere of an entire planet.
So where does your work tend to be picked up by the most when it comes to like, would it be military strategy? For instance, if Elon tweets a joke about nuking Mars, but you got to start thinking the way you said that maybe if something hit a polar ice cap on Mars or something and completely maybe after a couple thousand years, you got to start thinking that's what probably people are thinking about doing. If you're able to launch a missile or whatever that we have technology wise that can go into space, people say that we're probably not at that stage. We're probably a lot more advanced than they like to think in a lot of aspects of where our technology is. I mean, we didn't even know we were going to be on Mars and landed on Mars, and no one gave a shit. Like nobody cared, at least in my realms or fields or groups of circles, I would say. Everyone was like, wait, we landed on Mars? I was like, yeah, like, didn't we already do that? I was like, what? Like, no, this was an event that was like being recorded by NASA for like a couple of days. Like they had a live stream going on Twitter. Everyone was, but they were, I think at the time they were worried about something else that was trending, probably some celebrity getting like a new nail job or something. But I digress, but I lead into this category of like, if they start thinking about that, it's going to be picked up for military purposes of like, okay, let's talk to Brandon, who's good at impact craters, and we can start figuring out, well, all right, through your research, what have you found are strategic points? I mean, that's kind of the whole thing is like, you could hit a soft spot. And I know people don't like to think of like, yeah, the earth has a soft spot. Man, if it hits it right, you don't understand. Like, it doesn't necessarily have to be the whole giant, like, monolith size thing that has to hit our planet. It could just hit in a very crucial part that we don't know is very, very soft or crucial in some areas. I mean, in a lot of aspects, one little small one could really just wreck everything, could throw a balance off of everything as well too, and just end the whole planet as it exists. So you got to look at, maybe some people are out there when they're scoping out these planets, or they're looking at further exoplanets and researching ones that we can't live on that are in our solar system. Are they looking at strategic points that they could hit to maybe, with time, terraform it to be more habitable in case of an emergency situation where we might need to leave this planet and not go so far out?
Yeah, so I will
I'm
say
like a
that I
kid that you give a lot of candy to, and he's asking a lot of questions
no,
in
no, they're
class.
fun.
Okay.
It's very fun. They're fun questions. I'm happy to answer. Yeah, so I don't the military isn't contacting me about where we want to hit, where we'd want an asteroid to hit on Mars. I do, but that being said, on the other side of the coin, NASA is doing missions to see how could we redirect asteroids that we know we're going to hit the Earth, right? So let's say, like the don't look up scenario, there's a big asteroid that's we know is going to hit the Earth, or maybe there's a small asteroid that was going to hit like New York City, or some really big population center where even a small, well, relatively small impact, something maybe like the Tunguska event that wiped out a bunch of forest in Siberia. That's only like 100-meter size body. But if something like that happened like right over a big city, that would be a very catastrophic event in the world, right? You're talking about wiping out that entire populace of a city. Um, so if we knew something like that was going to happen, we would try to divert the asteroid, try to change its orbit so that it wouldn't hit the Earth anymore. Um, or so that where it hits, if it's a small enough one, that it hits over the ocean or something like that. Um, and so NASA has done like there's one mission called the Deep Impact mission, where we had kind of a manhole sized space, like yeah, like a manhole cover, like a big plate of metal that rammed into a comet at 10 kilometers per second or so, and made a nice crater. It wasn't big enough that it actually really changed the orbit of the comet, but it was a demonstration that we have the technology that if we wanted to hit an asteroid or a comet, we can. There's an upcoming mission called the DART mission that is going to hit the moon of an asteroid. So there's an asteroid, and it has a little a little asteroid that orbits around it. So it's got its own little moon. So this impact's going to hit that moon, and it's going to the idea is it's going to cause the orbit of that moon to change enough that we can actually look back at the asteroid and see how much it's changed its orbit, and then we can better understand if we did have something that was imminently coming to hit us, what do we need to send there to redirect it so it's not going to hit us, right? um, on the flip side, coming to your concern about what militarization of this kind of stuff, this is a ethical concern some people have about redirecting asteroids, is that if we have the technology to keep asteroids from hitting where we don't want them to, that means we also technically have the power to have asteroids hit where we want them to, right? And so that is an ethical concern people discuss, but I don't think we're a long ways off from that technical capability anyway. So I think it's at least at the current time, it's not a big concern, at
I
least
would
not to me.
I would think the most valuable thing about studying impact craters is being able to understand more about what space debris, or if you want to lump asteroids in with space debris, is out there. I mean, the possibilities of understanding what this impact could do, depending on the scales and variations of the different impacts, you would be able to tell, all right, we have a certain type of asteroid that always seems to form in these different types of shapes, more of like the ones we see on movies, like the lumpy type ones. We have these type ones that are constantly hitting in our solar system. So that means, that would be a best predictability of understanding them even better to be able to, I guess, counteract if one of them does eventually land into our atmosphere. I mean, it hasn't happened, and I don't. It kind of seems like a very, very far, long shot of it happening again, at least anytime soon. But we don't know. I mean, something can randomly just come in that we wouldn't have seen, and it's coming at a speed that we're not able to predict it fast enough and be able to stop it. But I think it's also like understanding your enemy a little bit better. Not necessarily saying that these are just used for bad purposes to our planet or bad purposes in general, but in a sense, when it comes to human life, it kind of usually is. I mean, whether it hits and it adds a beneficial chemical or beneficial resource to our planet at all, it still has a danger of hitting something in an area where a life might be lost. And that's kind of what you have to look at it too. So it's kind of like, I look at it like an informational code. I mean, the younger dries impact hypothesis. I don't know if you follow too keen on that one, or if you're a supporter of that. That's probably what happened. I'm more likely in like it probably did happen, just a multiple breakup of one asteroid or something that hit in multiple different areas. But that sediment or that black layer that they all talk about, the people that support that theory or hypothesis, that's an informational code of like a million something years. Like that's not anything that's really like I don't think people really take in because they see a little black line. They're like, what's that going to hold? I'm like, that's a lot of secrets. I mean, if you go to another planet and you're in an impact crater and you're looking, there's probably going to be a thin layer that's going to be very, very valuable information that you're going to be able to decode or be able to understand even more about what was this before when we weren't able to view it. There's a large gap of time right now that we haven't been able to view other planets. Maybe we had more gap or more knowledge and understanding than we did originally about the moon because people thought that the craters were volcanoes. But we're at this point now where we're going to be able to see even deeper of to what these planets were before and how they've evolved and changed on the course of time. And that gives us better predictability of what's going to happen to our planet, even though it's a different planet in general. It's still something that it's a good thing to be prepared, to be aware of this different possible scenarios.
Yeah. Okay. Great question. Lots there to pull apart. So
I'm trying. I'm new on impact craters.
no, it's great. So yeah. So in terms of like what I study a whole range of things regarding impact cratering. I mean, I just get fascinated about the process itself and what's going on. But there's a lot of interesting questions about planetary bodies that come out from impact cratering. Um, so one of the things you alluded to is like what's hitting us and like what's the hazard and what do these asteroids look like. So that I'm doing some work. One of my graduate students is doing some work trying to better understand how smaller bodies break up in the atmosphere, and we have these events that we call air blast or air burst, or sometimes people just call it a fireball. But it's essentially when a meteor comes in the atmosphere and the atmosphere is dense enough that the meteor just kind of explodes. And so we're doing some detailed modeling to better understand why some asteroids will break up and explode, while others that might be almost the same size will hit the Earth and make a crater. Um, so that's one of the things that we're looking into that is kind of connected to what you're saying about like what are the asteroids like and how does that change things. Um, Another thing when you're talking about these layers, right? Uh, we do have a lot of good evidence on the Earth of ancient impacts that happened based on what we call ejecta layers. So when you have an impact, when it makes a crater, it flings out a whole bunch of rock, including molten rock. So we have melted rock bits, and even vaporized rock. So when it hits, it will vaporize rock, and that expands as this big, what we call a vapor plume. And for a big enough impact, that material will spread over the entire Earth, and you can find it almost anywhere that you look. And so the Chicxulub impact, that's the one that killed off the dinosaurs. We've got this nice global layer that's about 3 millimeters thick, and it's got these little tiny droplets of stuff that condensed from rock vapor, and then rained back down on the Earth. When it rained back down, it might have caused some like global wildfires, which is not good for dinosaurs. But also that raining out also probably put the dinosaurs almost into like a broil, like putting your oven on broil for about an hour. So that's also not good for dinosaurs. But what it does is in the geologic record is it leaves this nice little layer in the rocks that we can find, right? I told you before that, there's not that many craters on the Earth. Depending on if you want to count some small craters that we call secondary craters, there's 100 or maybe a couple hundred craters that we found on the Earth. And like I said earlier, that's because after a crater forms, we have rain and weathering, and we have plate tectonics that will just completely remove the crust that these craters formed in. But what's fascinating is we can find evidence of impacts that happened almost 3.5 billion years ago because we can find these layers of these condensed little droplets that fell out in the atmosphere. And some of these are much thicker, than the ones that we found associated with the impact that killed off the dinosaurs. And so we can infer that this layer was probably made by a 100-kilometer diameter impactor rather than this Chicxulub impact, which is more like a 10-kilometer diameter impactor. So we can use these layers to learn what was hitting the Earth and when we find them. So and probably in the future, like you said, we can probably find these kinds of layers on other planets too.
Or doing scale mapping of being able to show possible, I guess, timelines of what Earth would have been like without some of these possible craters as well
Right.
too, or impacts. I mean, that to me is fascinating. Like, a lot of people don't like, they're like, oh, that's in the past. Like, I know some, especially general public, I would say, if you ask, like, you could see a possibility that could have been Earth. If you would have just said that, they'd be like, I don't want to see it. I want to know about our history, or I want to know about the future. Like, do you have Bitcoin money? Like, that's what people want to know. But to me, this is interesting because I wonder, like, what would the Earth be like if we didn't have certain asteroids? We'd be living in a whole different thing. Would human life even still be here? Would there be a possibility of us evolving to become from one of these things? I mean, that's the main question that gets asked amongst, like, there's a theory that we came from Mars. Now, if you believe Bill Nelson, where he's like our origins and all this, I'm like, all right, dude, hang on a second. Don't blast the public with that info just yet. But if we stick along that theory that we came from Mars, like an asteroid hit Mars and some space particles floated into our atmosphere and we evolved from that. I mean, that's a huge thing right there. Like, that's very, very crucial, and just how powerful that these impacts or these certain scenarios are, not just in devastation, but in life giving as well too. We talked about resources in the beginning, but just it, to me, that's fascinating. For a lot of people, it just seems like it gets lost out there because it's hard to see when it's not in front of you or when you don't have a picture of it. But this is where technology is going to go. I mean, if you looked at the predictability of an impact and you're able to pull out the sediment or whatever ancient microbes that could be in there. I mean, that's I had a guest on here, Stephen Hunt. He studies ancient microbials across the seafloor, and he talks about it's only like it's couple million year process of that stuff being built up, but people want to use it as a resource, and you understand that, like, that took forever to make. It's not something that's going to be like long lasting. It's going to be for however long, couple hundred years maybe, and then it's over with. It's kind of like fossil fuels, what people talk about. I mean, that's fascinating because these little organisms that we really can't see through our eyes, but we can see through a microscopic lens, probably hold some ancient DNA, some deep aspects that you'll probably find in some of these deep layers of the earth as well too. I mean, in a sense, what we're living on is kind of like a person's lungs who's been smoking for 60 years. Like, everything that we know is normal, we don't know what normal is. I mean, if you dig deeper down under that, you're going to find like the bare, fresh, newborn layer of that freaking earth.
Yeah. So
A lot again. I'm sorry.
yeah, no, it's good. So I think, yeah, in terms of like getting the public excited or interested in cratering, um I think it's actually a bit easier than some other sciences. There the ability for them to engage the public. Part of that is just because um, the impact cratering is a very intense event, and it's, even though I like to think about it as a geologic event, or it happens very quickly, right? So even the largest craters form in a matter of an hour or so, right? And the earlier times are extremely dynamic, and I think kind of that the mayhem aspect of it is something that people can connect to, especially when you talk about like the death of the dinosaurs. A lot of people like dinosaurs, and so just like understanding how that happened is I think of interest of people. I think what a lot of the public maybe doesn't appreciate about that is like, even though that is a day of mayhem and destruction, it's really, also our origin story, right? It's like we talked about, that really people wouldn't be anything, we wouldn't be anything like we are if we didn't have that impact 66 million years ago, right? So
I think that fear leads us down the wrong road, though. I think it sparks interest in the wrong way. And I think that leads to like the government taking over or some type of like protocol or something that gets enforced where I'm not like a mandate thing, but like just like an area of like, we're going to install this or we're going to do this. Like, we're going to make a defense system that blocks asteroids. Well, my issue with that is where you said there could be some ethical concerns is, yeah, it's important to block asteroids from hitting the earth because people now are scared that there's going to like a don't look up scenario where it hits the freaking earth. And you get this giant explosion that happens. Everyone dies. Leonardo's gone. But it also leads into this area of what are we going to be messing up when we have something that is a defense system where it does cause, maybe we can't see it, but it pushes an asteroid away and it hits another planet. The next thing you know, you're going to have a whole alignment balance. I'm not saying that we just have to take it, like take a hit on the shoulder or something like that, but that I don't think is the proper way to really get it going as well either. See, my issue is where I start thinking about scenarios like this is when we start talking about all these possibilities and we talk about, all these questions I keep tossing out. If I'm thinking of it, someone else is thinking of something like that. And I start wondering, like, this is how people are going to sway this to make sure the research starts going in a different direction than maybe what it would be more beneficial towards. Where I'm looking to someone like you who can tell me the beneficial stuff so we don't get so down into like the military negatives. Because I mean, military is needed. I'm 100% in agreement with that. But it also, they don't do stuff in the best of ways. Like when you learn about asteroid mining, you start realizing people are greedy as hell, man. And it gets into this layer where I start understanding, like, I rather get the information out of what these things have rather than trying to find a way to maybe scare or maybe make a misunderstanding of what they could possibly be used for. Which, if I tell you if it's the probability of being able to predict an asteroid hitting the planet, that could be swayed in so many different options for getting people to go down the wrong path when it comes to research or maybe innovation into discovering or utilizing another resources.
sure, yeah. So I mean, one thing I'd like to clarify is like the all the asteroid redirection stuff right now is through NASA. So I wouldn't necessarily consider it a military enterprise directly, but there are some, you can make connections if you want, of course. What I say is like, most of my research isn't about, asteroids hitting the earth and killing off dinosaurs or people, right? Most of my research is about what impacts do to planets. They're a major driver of the evolution of planetary crusts. They will affect whether planets are habitable. They also give us insight into what these planetary bodies were like at the time that impacts were forming. So what a crater or an impact basin looks like will tell you about what the interior of the planet was like, or the body was like at the time of the impact. So uh, one of the more exciting things that we're doing with impact craters, we're looking at these big basins on icy moons that we think have subsurface oceans, right? And there's a lot of questions about how thick is that ice shell, and depending on, we really want to know how thick that is, because if we want to know what's going on in the inside in the ocean and whether there might be critters in the oceans of these icy bodies, we need to know how thick that ice shell is and what's going on within it. And so these big craters, uh, essentially you can think about it as punching a hole through, into that ice shell, and they tell us what the ice shell is like, and how thick it might be. So that's one of the themes of that I'm really interested in.
I
I'm
like
also
the
oh,
discovery
sorry.
I like the discovery aspect of that. Like just being able to, because I mean, it might not be good for whatever life is on that. Like if you're talking about like, but it's good for studying if you're an observer watching that type of thing happen on an icy moon. Like we don't know what's beneath that layer. You know, the movie Journey to the Center of the Earth. Like that, we didn't know. Like half of those movies talk about like there's another layer inside of Earth or something like that. That dude, if that's you're examining another planet or examining an icy moon, for instance, and you're only able to see the top shelf layer, and maybe we don't have technology or be able to go through that, then you look at like, okay, well, one of these a crater just hit or an impact just happened. It created a crater, and now we can see deeper into it and we can understand it even more.
Yeah, that's exactly right. We only when and until we send something there to dig in or drill in, all we see is the surface. But these impacts, are a probe into the interior, and they can give us some information about that. I would say that the other thing that I'm really interested in, and I think it might, like, it depends on what the public's interested in, but I'm very much interested in how we go from uh, just gas and dust around a star that's being born to having planets like we have today. And the way that we get from that dust and gas to planets is through a bunch of impacts and mergers, right? So early on, everything's coming together really, really gently. We have, little dust bunnies that come together to make bigger dust bunnies. But eventually you have moon and Mars sized bodies that are colliding with each other to build things like the Earth. And understanding how those, the details of those kinds of impacts, and the dynamics of the early solar system can actually tell us, why do we have, you know Mercury, Venus, Earth, Mars, and then we have, Jupiter, Saturn, Neptune, and Uranus. Why do we have that kind of a planetary system? With the terrestrial planets and then the gas giants where they are. Whereas when we look at exoplanetary systems, we see a whole menagerie, a zoo of different types of systems, right? And it comes down to, you know the dynamics of how these bodies are moving around and how they're impacting each other. So that's another thing that I'm very interested in. The main way that I look at that is by looking at meteorites that may record some of the processes that were happening. So they might show evidence of these impacts that were happening 4.5 billion years ago. Um, but I think that's another really important thing for understanding our origins is, how do you build the Earth, right? It wasn't always here. We were once just a bunch of dust and gas spread out in the protoplanetary disk.
What do you consider that luck? Like I know you could say like just a random mixture of things colliding together that created what we have now, but I would be like we only call it luck because we didn't know what was before that. You know what I mean? Like we don't see the possible scenarios. Like if you're able to technology goes farther, you're able to predate farther. Like if we had an asteroid, we all know asteroids or maybe some type of debris or some type of break off happens and it hits in our ocean. Now we don't see it, but if you're able to pull out one of those meteorites or something like that, and you're able to pull the code from it, like get to a point where you can drill and get crucial data to be like, where was this thing from? Where did it go? And what information does it have stored in it that could tell us what's further out there? I mean, we don't know the possible scenarios of what life could have been like if all the planets didn't align like it did, if we were on a different planet. We don't know any of these hypotheticals that are out there. And they're not bad questions and they're not sci-fi. They're good things because I think that also helps with our human evolution as well too. Like you talk about the evolution of a planet or maybe the evolve whatever you yeah, it would be the evolution of a planet. If it was made by asteroids or if it hits, you could tell from these impact craters, for instance. Well, in a sense, that also has an impact on our evolution as well, too. Not just on the base of a land, I guess, instance, I would say, but a mental aspect as well, too. The information that we're running off of is information that we're able to kind of predict of where we come from. And that only keeps excelling farther and farther and farther with the more information that we have. And I mean, we're learning, like I said, science is rapidly changing. And that's where you look at this aspect of like maybe that what we consider luck could possibly be this could be the worst outcome. You know what I mean? Like that's what we consider the best could be honestly the worst outcome if you really think about the possible scenarios that we're not able to see or we're not able to know yet. Like imagine if there was more than just one planet that could sustain life. Imagine if it was a multiple, like Mars could have done it. They all could have ended up individually different depending on how all the planets or the processes come together. But we consider this one the rarest and the odd off chance of why did this happen? People go Big Bang, whatever. You can look at this aspect as like maybe this could possibly be the worst outcome, and we could actually be what we think the best could honestly be the worst, and there could be possible others out there where you could have an alternate timeline where I know I'm getting really deep in the weeds here, but you're getting like into this alternate timeline where you have the moon, all these different things could have been completely different. Our whole galaxy could, as much as we know it, could be completely different just on a stroke of something as small as a tiny space rock.
Yeah, so I think it's there's a lot there again too, but that's great. So in terms of like whether we're lucky, whether Earth is just really lucky chance that we happen to have something like Earth come to be, or our system is just right for life. I mean, in part it kind of has to be true that it's just right for life as we currently know it, right? Because it is just right, and we're here. The thinking, I think the thinking within the scientific community has changed a lot, with the discovery of more and more exoplanets. It used to be thought that having planets around stars was a really rare thing, and was unlikely to happen. And now we think almost every star probably has one or more planets. And as I personally believe, as we get better at detecting planets, we'll see there's more and more systems with more planets. And I think uh, I think they're probably we probably are a bit of a outlier in terms of systems, but I don't think we're unique by any means. And as you alluded to, I think there probably are other systems that are you know even better, and there might be many a few planets and several moons within one system that are all habitable. Um, so yeah, there's a whole range of possibilities when we start to consider exoplanetary systems. Um, the other side of the question, you were talking about like how we can use the meteorites that come to Earth to understand what's happening further and further out. The way that I like to think about the meteorites is that they help us understand things that happen further and further in the past, because a lot of them are very ancient rocks. And it's it's a really fascinating part of science to me to try to understand what was happening in the early solar system. uh, and part of that is because there was so much happening. So I talked about these dust bunnies and impacts and stuff, and told you this nice little story. But what I didn't tell you is within so there's 4.5 billion years from when the sun was born till today, right? All of planet building, building the gas giants. So Jupiter was formed within only a few million years of the sun, right? And then maybe within 100 million years or so, the Earth was formed. Didn't look quite exactly like it does today, but it had almost all of its mass was accreted, and we had the moon and everything like that. So the early solar system, everything's happening really fast. There's a ton happening. It's very dynamic. And the only real evidence we have of it is what we see today, where the planets are right now, and also what we get from these rocks that formed 4.5 billion years ago when the solar system was just forming. And so it's a really it's a really exciting and fun thing to think about, is what was really happening there. But it's very important, because if we don't understand how our solar system came to be, it's very difficult to understand all these other exoplanetary systems and how they came to be, right? But they give us another piece of the puzzle, right? By trying to understand those exoplanetary systems, we might also be able to better understand our system. So it's kind of this nice feedback loop between, you know, increasing our understanding of our solar system's formation, and then also increasing our understanding of how these exoplanetary systems came to be. And through that, once we really have if we really know exactly how all these systems come to be, then we can know how lucky we are, right? Is it really rare to have Earth like it is, or are there lots of places with things like Earth, or are we really unlucky and there's lots of places that are much more, are better for life than Earth and our solar system. So there's a lot still out there to understand, but it's something people are definitely thinking about.
I would like to know the question of why are the planets in our solar system so individually different? Like I understand like different sizes and different comparisons, but like Jupiter being like a gas giant and just the surfaces are so and people say like, well, it's the measure from the sun and this one was just far enough to sustain life. I'm like, yeah, but there's got to be way more than that. Like when they were all compiling together, they didn't just all just be like, all right, we're all planets, we're all going to line up in this order, first everyone take a number and line up. That's not what happened. It happened in some conglomerate and some event that took place. I mean, if you want to say it's the Big Bang or whatever, but it individually formed and each one has such a distinctive characteristic on it, and we're learning more about it, and that's changing. Like didn't Neptune's whole entire surface just change recently? There was an article about that just
Yeah,
got published.
its temperature is changing faster than we expected. Yeah.
I mean, Bill Nelson was the one talking about how Venus is like a cloud city, and it's like we can maybe make propulsion systems to live up in the clouds, or there's another option we didn't know about, which was beneath that cloud of gas is actually a more habitable layer. So if we can make a system under there, and you start learning like are they as uniquely different as I'm thinking, or as the general public can see it? Because like we talk about Mars as like a barren wasteland, and Mercury, whenever I think of that planet, I just get like a dry throat. I just want to cough. And it's like Star Wars. It's like you're looking at the whole entire thing. Like I've been recently playing a lot of Star Wars, so you're getting involved in that, and you look at the galaxy map and everything. You see all these planets, how they're all individually different, all very very unique. But is it kind of like wristbands? You have a different color wristband, but they're interchangeable in a sense. Like maybe after a certain amount of time or a certain amount of condition changes, you start looking at terraforming again and manipulating and being able to fix it to make it more interchangeable. I bet you all of them start with the same template, like every Call of Duty, but there's just these large, dramatic, long time period scales, maybe for us, but not to the actual like global solar system, I would say. When you look at like these millions and millions of years that have just been these small little buildups and changes. Like you don't notice every single cigarette you smoke causing an effect on your lungs, but when you're 70, it's you see the effects. So I look at that like with the planets. Now, over these millions of years, they might have started off on the same thing, like these same rocks, and they just formed in different ways. And it shows you the different comparisons of why this one generated this way and why this one generated this way. That means what could possibly change it to make it an exoplanet or make it just like the conditions that, because I mean that's all research is really not research, I should say, but that's all like what people are really hoping for with like going out into space is finding exoplanets and finding more habitable civilizations and also getting to understand our universe more. But when you're understanding another planet, you're also looking at other ways to be able to change it to something that is habitable for our life as well too. How can we do more research here and actually not have to worry about dying for being on it for 10 seconds, that type of thinking. And I think that they're all kind of probably the same template, but they've just been drastically over time in the long scale time period of human life, but short scale to the universe. They've just had these individual add-ons or these adaptations to it where it's evolved into what it is now.
Sure. Yeah. So I think that's a fascinating question.
That
And
doesn't sound crazy though, right? Like
no,
that's
no, no.
okay.
I've got great answers. I've got some good answers for
I'm
you. No,
over
it's
here
not.
like,
Your
fuck,
questions are
I think I said something stupid.
no. Your questions are. It was a great question. So it kind of depends on if you're. Sometimes in science we talk about people as lumpers or splitters. So if you like to make things all similar and put them in your collection and say, well, these things are all this type and these things are all this type, then then there's only a few different types of planetary bodies really. We either have the rocky terrestrial bodies that are, sub-Earth to Earth size. Then we don't have any in our solar system, but we have things that are maybe super Earth size. And then we get up to bodies that are Neptune, sub-Neptune to Neptune size, that have gassy envelopes, and then up to things that are more like Jupiter, right? And so if you think about it that way, you in our solar system we have some rocky bodies, and then we have some gas giants, and they're actually pretty similar, if you think of them, that way. That being said, but if you look at Venus and the Earth versus Mars, like they're very different, right? So they have a whole different history, and over after they just initially accrete, there's a lot of different things happening that have pushed them to be so different, right? And I think it is. I would agree with you that really all the planets in our solar system are very different, and probably when we go to exoplanetary systems, we'll see a lot of also very different places. But if we see enough different, enough of the range, you start to see these trends, right? And you can start to see, like, okay, why do these things that are like Mercury look so similar to Mercury, and why do these things that look more Earth-like end up looking more Earth-like? So I think there's a lot there. The other point about this is that uh, you know there is a lot of chaos and chance in even making our solar system. So there's people. So I don't run these kinds of codes, but I have a bunch of colleagues who run codes that we call accretion models, or essentially what they do is you start a fake solar system with a bunch of what we call planetesimals, which are just asteroid-sized bodies, and we watch it, we have all the physics perfectly in there, and we put them into big supercomputers, and months later we see how all these planetesimals ended up interacting with each other and building up planets and things like that. And what we find is you can start with almost the exact same conditions, and you can end up with many different outcomes, right? And so you could end up with one out of 100 ends up making something that looks just like our solar system, maybe, or maybe it's 1 out of 1,000 or 10,000, right? But then, with the exact same starting materials, you can end up with a completely different system because of the random chance and chaos involved with that. And so so you can get extreme diversity just from starting with the same stuff, right? But when we think about exoplanetary systems, we're starting with different kinds of stars. The disks that we start with are probably all different, and so there's just a huge range. And so I think, when you said it's like Star Wars or whatever, I think probably that is a reasonable way to look at it, is that all these systems are going to be unique, right? But if you see enough unique systems, you can start to make these connections, and start to classify things, and start better putting them into your stamp collection.
Is there anything in so far that we know about our solar system that just maybe isn't known, like unknown, like just things we can't have an explanation for? Like we understand it's like this, but we don't know how it became so.
Yeah, I mean, there's a bunch. So one outstanding uh, mystery that's a pretty big one is why Mercury has such a big core. So Mercury has a metallic core that's much bigger than we expect, and so that means the rocky outer part, the mantle, is quite thin, and there's some ideas, but we really don't know. So that's a pretty big mystery, in terms of just like how this planet got to be the way it is. I mean, there's a lot of big mysteries on all the planets, so it's hard to pick just one.
Let
But
me let
but
me let me just say this. This might be a really dumb question, and I'm even afraid to say it, but is it a likely possibility that I know we're all just rocks in space and some are gas giants and all that, but are these just asteroids that evolved this way over time to create the conditions that they have based on maybe an impact crater or some type of asteroid or whatever impact that happened? Like, could that be like that? Like the way you just said with Mercury, why does it have this metallic core? I mean, it's the same thing I heard when I'm talking to someone about asteroid mining. We don't know why some of these meteorites have a certain type of element in it, but they do. And you're telling me if one got stuck in place or one stayed somewhere, it was giant enough to just float there. And eventually, after time, composites of dust or different cosmic matter that ended up hitting it, maybe things that we don't have a perspective in on yet, or a different field maybe, that it evolved and created what it is now over that long general period of time. Like, to keep in track, like a T-Rex and a Stegosaurus are farther apart in time span than the Stegosaurus, or the no, than the T-Rex is to the cell phone. Like, that's a fucking, people think of like, oh no, dinosaurs, same time period, right? It's like, no, there was a large amount of time where they weren't together. So think of that. The T-Rex or the Stegosaurus to the T-Rex is farther than the T-Rex to the cell phone. So you got to look at like the time span of like maybe an asteroid, or if we're all like Earth, for instance, if it was just a giant hollow rock, nothing, but then, or maybe it was just a giant rock. Then it just started filling, and after all this composite of materials, much like if you drop a ring in dirt, you got to dust off the dirt. It's kind of what these asteroids do. I mean, is that so far off in thinking? Am I way out there?
I mean, I think your thinking is generally right, that the, if we were to go to an asteroid, this you could think about it as something, a piece of what could have become part of the Earth, right? But that, if you're out in the asteroid belt, it didn't actually end up becoming part of the Earth. But yeah, essentially the planets are built up through taking a bunch of these things that were probably much like the asteroids and collecting them together. It ends up happening that probably, you collect a bunch of asteroids together to make a moon-sized thing over here and maybe a Mars-sized thing over here, and then you start collecting those moon and Mars-sized things together. But yeah, it's just, if you think about it, yeah, we're just built up from kind of asteroids, through a whole bunch of them collecting together. That essentially is what made the Earth and the other planets.
So we're literally like an ant on a piece of bread. And right now we're just whittled the bread down to like a couple of crumbs that we're just going off of. You got to think
Sure.
though, if that's the possibility, or if that's the likely thing right there, and then you got to look at all the metals and all the resources that have sustained us this far. Maybe we might have done it at certain rates. Like maybe if we would have started off in the beginning and had a time span of the most beneficial ways to use our resources, we could probably make it last way longer. But still, to think that like this is something that just had a vast, like just the amount of resources that were here for what we've built so far, like that's pretty fascinating in its own. I think a lot of people take that the wrong way sometimes. Like they just look at like there's only a limited amount of resources. They're more thinking selfishly in a sense. Like I'm like, yeah, but we did a lot in that short amount of resources. Now it's time to find another option or avenue to be able to make a renewable energy source or something like that. But still, like that wasn't like just like, oh, this is here for you. Like you have $10. No, that was just something that we found on the street and we've used it to the expense of what it is now, which is like $9.99. And I think that's fascinating as hell. Maybe I might have thrown us in a weird deep hole. I know I was talking about the government earlier, but that's just like, to me, that's just interesting where I start looking like I have these questions about space because I think a lot of people get a really bad seventh grade science class about space. And then besides all the alien talk that gets them interested into it, I think it also kind of skips over the miracle of what we have today. That is, in a sense, I mean, if you really talk about it in the way that we've talked about it, it's baffling. And I can understand where it brings in like religious tones where people go, well, God created the earth in seven, then he rested, whatever. I'm not into that. But I do have a really kind of another weird question for you. When it comes to ancient history, how much of this can be like the ancient biblical stories? Because you can trace like the flood. Every kind of society had a flood like story. How much can you trace to like maybe a lot of these people were seeing meteorites or comets? Like when they talk about fires raining from like the reason when we talked about earlier, just to clarify on the fear thing of like people being interested into it of like, oh, a giant like kind of like the Netflix movie. But that's what people call an apocalypse. Like when God and the devil or whoever fight, that's an end of days type scenario, which would be a giant asteroid. Everything's on fire and all this type of sense, like a very, very doomed scenario. How much through like ancient like Christianity or these types of things, you might not know the answer to this, but I'm just tossing this out there. Could some of that possibilities be a trace to meteorite impacts or some type of comet impact or something like that? If something hits an ocean and there's a flood, for instance, if we bring it to the Noah story, it's an interesting thought. I had to toss that out there.
It's an interesting thought. So there are some fringe there's some fringe folks who have made claims like that, but the if you're thinking biblical times, that's actually pretty recent in terms of like understanding geologic processes, right? And so if there was an event like that that happened on the time scale of the biblical times, it's something that should still have evidence today. That being said, maybe some of the stories, maybe people saw a fireball or something like that, and base some stories off of that. That could be a possibility.
Well, the
The story,
biblical stuff is older. It's a lot of biblical roots are in paganism as well too. There's like
yeah.
the Adam
Well,
and Eve
I'm
story.
talking even on the timescale of humanity. Like we don't have any evidence for like a big impacts in the history of humanity. Even big. There are some impacts that happen, but not anything big enough to be like a global kind of scale event. But like I said, air blasts happen. Something like Chelyabinsk happens on the Earth every 20 years or so. Something like Tunguska, which would be quite devastating, happens every 100 years or so. But we don't. Yeah, but there's not any good evidence like connecting it to specific stories or locations or things like that. But it's possible that it could inform some of the thinking.
Yeah,
The
because I know
story of
some of the people like with the Younger Dryas, they talk about like the city of Sodom, like that one. Well, if you look at the religious text, they talk about it just turn it to like a pillar of salt. And I go, well, what would that be like code for if you were going to put it to like a more scientifical reference? Would that be a sinkhole event? Would that be an earthquake? Would that be some type of like, people talk, they still have ideas of like where Atlantis could be. Now, if Atlantis got sunk or it was some type of shift that just the earth layer shifted and it sunk into the water or something like that, that's a possibility. I don't think it's future like society or anything, but I look at this like these religious texts. I mean, they were writing down something. Now, if they put it in a more of a mystical way because their understanding is not the understanding of we have now because of time and science and all that. I tried to like look at a lot of these because there's the old class. It's like Bible to literature references or something like that. And it translates a lot of the old Bible stories to literature reference. And a lot of it does root back to pagan roots. But a lot of like the Younger Dryas, like you were talking about, some of the fringe theorists kind of link to this. Some of the Younger Dryas impacts, when they talk about Atlantis and all these types of things, the stories that we know, like from either if it's just a fake story or if it's some type of biblical reference, they talk about it actually like the Clovis people. Those people were all wiped out, and then so were everything else that was around that time period. It was just all extinct. Now they said that it could have been everyone was hunted to extinction or something like that, but then it could have been the Younger Dryas, which leads into that. And I go, okay, then if you're trying to explain a lot of these references, which are they seem so creative where people just go, they were created by psychedelics. I'm like, well, maybe they weren't just created by psychedelics. Maybe they were like star mapping when people would see the horoscopes in the sky or something like that. They were writing down events, but they only knew the English that they knew or the language that they knew. And this is how they were able to depict those. It's like a giant fiery thing in the sky was just a meteor or something like that. I don't know. It was just an interesting thought I had.
Yeah, so yeah, so I think it's a reasonable thought, and it's not a bad thing to think about, and certainly uh, I think it's a plausible idea. But what I was saying is just that like I think there was some scientists tried to suggest that there was a air blast over Sodom or Gomorrah or whatever. Try to find where it would have been in current day, and then found this town and found some what they said was evidence of this air blast. But then if you look into the paper, that their evidence actually like isn't consistent with what you'd expect
Damn it.
from a meteor. So it doesn't really work. It doesn't really work out. So they were trying, like, sometimes, scientists are people too, and sometimes, like, you get this idea, maybe these people had this idea, and kind of, they weren't experts on the impact side of things, and we're like, oh, well, this was in the Bible and this story makes sense. Like you said, when you say it, it makes a lot of sense. But when you actually go and look at the evidence, it's like, well, actually, this isn't consistent with an impact happening. Um, so, those sort, like I said, it's still possible, something like that did inform some of these stories. Certainly there are definitely, like, peasant fables and things that people think were related to meteors. In fact, before meteorites were thought to be rocks from space, before people actually believed they were, rocks could come from space and cause, meteor events. Um, People actually would just write it off as peasant fables. They said the same thing, like, oh, well, these people are out of their minds, just, making up stories. But eventually scientists realized that, oh no, these meteors are a real real thing, and these rocks probably are coming from space. But it took a long time for scientists to appreciate it, actually.
My thought on that was just because of, like, we only know, like, okay, we can be able to trace or be able to tell meteors more and more every single day, like impacts or maybe possible impacts or something like that. Not saying that it happens every day, but we're able to, with the information that we have, we're able to classify things more. And I wonder if you could probably chalk up some of those things that happened back in the day to what we know now as, oh, it was this and oh, it was that. I feel like a lot of these stuff, or maybe things that are talked about in religion, do have realistic aspects to it, but I bet we now have a different scientific term to be able to classify, okay, what that was. Like Moses, for instance, seeing a burning bush, the possibility that it could have been the cicada bush, which is a psychedelic, and it is a bush that they were burning, and it does cause you to trip, or you would see something like someone parting the seas. Now, I'm not knocking religion in a sense. I'm just saying, from a scientific aspect, I don't think all these stories are all, like, nobody's that fucking creative. I'm sorry. I have to say it like that. Nobody's that creative. But I think it lands in this aspect of, like, it makes it more interesting to try and understand it deeper, because I bet if with the information we have now, like you, like looking at these meteorites and being able to trace back history, looking like for an origin and an aspect. I mean, with the information we have now compared to the information we had back then, we could probably classify a lot of the stuff that they were seeing, or a lot of the stuff that they were trying to understand, but it mostly got chalked up to religion. I mean, for the longest time, even in my youth, for instance, everything was kind of chalked up to religion. Now we have, like, more scientific evidence where, like, okay, you're seeing a large amount of people not be religious anymore just because they maybe choose to worship at home, or maybe they become more spiritual. Not knocking religion. I'm just saying, because a lot of people are starting to see more science, more of this aspect of things. We're starting to understand more, which is like the progression into what I was going to bring up earlier with AIs, for instance. Now, if you can have, like you were talking about, where some of your friends were coding, be able to create possible scenarios where, like, okay, this 1 out of 10,000, you get the Earth solar system or something like that. Do you think AIs could fill in some of that lost data of how the Earth came to be, or how all these possible scenarios in our solar system came composited, like you were saying, all these dust mites that came together? Do you think it would fill in a lot of gaps that we're missing, maybe with data chunks that we don't have? Because I look at it at, like, a timeline of, we have A to Z, but we're missing like 3 letters or 4 letters here out of the alphabet, where I'm like, we don't know how that came to be, but we know how it ends. You know what I mean? Like, I feel like AI, especially with, and I'm not trying to let machines take over the whole thing because I'm so against that, but I'm seeing the very beneficial aspects of where we could use AI. And I think that would be probability, or being able to predict, not necessarily an impact, but be able to predict a causation that we might not have 100% the full shooting gun on, or smoking gun, I would say.
Yeah, so yeah, machine learning and AI are really becoming prevalent across sciences, and people are doing a lot of creative, exciting, interesting things with them. And the problem of building a planetary system that looks like ours, certainly, it fits in that realm. And there are people who are using AI to kind of classify outcomes and try to better understand trends trends that might be, hard to recognize in, what is it about these, if you do 100,000 simulations and 10 of them make nice habitable zone planets, what is it about those simulations that resulted in that? And the machine learning and AI is really good at identifying those kinds of trends. AI is also used in like detection of planets too, to a big extent. So just looking at the gobs and gobs of data that are coming down from telescopes, and trying to sift out, and find the needle in the haystack that is the actual planets, right? Because you have to stare at these stars for a long time before you actually see the planet. So the AI helps with that kind of identification too. So yeah, and I think it's really exciting to see where AI is going in science. Um, but yeah, there's also a lot of interesting, like, scary bits about
Yeah,
it,
I was
right?
just gonna
Like,
say, my ending point was just wait till the military takes it over.
no,
No,
I don't think, not scary that way.
no,
I guess in terms of science, like,
it's just
the
excelling
AI
rapidly.
gives you an answer, but you don't know how it
Yeah,
got that answer,
yeah,
right? And so it's what sometimes we call as like a black box. Is like, okay, so
yeah,
this
yeah.
machine just told me this answer, and I have no idea where this actually came
I've
from.
I've had
And
some of the
sometimes then you apply a different data set, and then it just doesn't work at all. So AI also has some issues,
I've
but
had
it'll be
s-
interesting to see where it goes in the
I've had
next.
some of the biggest people in AI talk about this stuff. Dude, the only fear I have for it is it's rapidly increasing so fast that it's just doubling our human intelligence evolution. And I'm like, I hope that it just doesn't outpace us in a sense where we can't still understand it. Because I mean, eventually it's just going to get to a point where we're not going to be able to understand anything that's going, and then you don't stop that progress train. I mean, I don't think, I mean, whatever. There's animals that are probably around longer than us, but we're excelling so rapidly. They're probably like, what the hell? Like, you left me in the dust like it was a race. But we don't have to get into all that. Brandon, we've been talking a little bit longer than an hour. I'm sorry for holding up with my questions of way out there. I'm sorry. They were some out there questions. I'm gonna listen back to this. Like, what the hell was I talking about? But it was fun, dude. I had a pleasure or a blast, I would say. It was my pleasure to have you on the show. I'd like to have you back on again as well too. If you're willing to stick with the insanity one more time. But Brandon, it's been a pleasure. Where can people find you, man? Links.
Yeah, I guess just if you want to Google me, I'm not on Twitter or anything like that, but
Good for you.
you
Good for
can
you.
you can yeah, I was on Facebook and Twitter for a while, but I finally just was done with it. But yeah, you can find me on like university website. I have my own website. I think it's brandoncjohnson.com. But you can Google me too, and probably find me that way. Um, but yeah, I had such a fun time chatting. So thanks for having me on.
I'll link all your links in the description. It's a good thing you're not on social media. I'm not doing it at all either. Finding a large majority of people are starting to kind of get that cut off a little bit, just become too much a little bit at times. So that's a good advice for anybody out there listening at the end of this episode. Maybe reduce your carbon footprint and social media. I don't know. I had to add in like an environmental tip. All right. Thanks for listening, everybody.